hello everyone, good day, good evening, good afternoon, wherever you are. So I'm hoping you all are having a great day, especially now that the US election results have finally come in and Joe Biden has actually won, has been declared to win the elections. Today, like Kartik said, is a discussion of sorts on chaos engineering, primarily because there's a lot of community interest around this as a discipline, and there are a lot of folks who have varied queries, not just around specific products or how chaos engineering as a discipline is, but they are also very curious about other background factors that are contributing to this need, and going ahead how they can possibly adopt it into their workplaces. So this, like Kartik said, is an evolution of that line of thought, and we decided to have this panel for that purpose. First off, I think I'll start off by introducing myself, because I'm sure none of you know me. So I'm Divya, and I work as a senior systems administrator with HSBC. I'm just really a very curious person at heart, which is possibly also why I got interested in chaos engineering as a discipline, because I really like understanding and really like understanding causes behind failure, and how to trigger failure into a particular application or into a system, and how best we can actually recover from that sort of an event in production application. That's been my side project for nearly a year now, and I'm trying really hard to get my side project merged with my real life job. There's progress in that regard, but as you all know, chaos engineering is not an easy discipline that is bought in by all enterprises. So that's a bit about me. I shall go in no particular order. So I think a lot of us here are familiar with Kartik, who just introduced himself before me. He is the maintainer of the open source chaos engineering project Litmus Chaos, and he's an architect at Maya Data. He's passionate about DevOps, data management and reliability, and has worked in several projects around containerized storage, infrastructure as code, and CI/CD performance benchmarking. He's also someone whose brains I pick on almost every day of every week, Monday, during our SIG documentation calls. So, and he's a very dear friend as well. So, hello there, Kartik. How are you doing today? Hopefully good.
Yeah, good. Thanks, Divya, for the intro. I think awesome.
Yeah. So, next on my list is Sylvain. So Sylvain is the CTO of Chaos IQ and the project creator and maintainer for the Chaos Toolkit. In his words, he's always one PR behind, and ever since I have started my Chaos journey, I have been following yours and Rasmal's tweets and blogs pretty frequently. So it's an honor to actually be here on the panel, on the same panel as you are. And I'm looking forward to picking all of your brains regarding chaos engineering. So hi Sylvain, and I hope my introduction was has encapsulated your experience pretty well.
Yep, totally. Yeah, that's fine. And I'm really happy to be here with you guys. Thank you very much, Divya.
Welcome. Next on my list is Kristen. So she has a CS degree from the University of Reykjavik and has been working in IT for 14 years. Starting out as a Unix administrator on IBM AIX, she moved to Linux and has eventually drifted into automation. And it's, I think, just about 2 years, Kristen, that you started your Kubernetes journey, if I'm not wrong. And we joined NetApp 1 year ago, where she discovered the benefit of chaos engineering and has been working almost exclusively with Kubernetes clusters on AWS, but they're also working with Google Cloud and Azure. So, hi, Christine. How are you today?
Hi, thank you. Excellent. How are you?
I'm doing good, thank you. Our next panelist for today would be Sumit, who is a principal engineer at Intuit and a maintainer of Litmus Chaos. He leads reliability engineering with a focus on performance testing and chaos engineering. Currently, he is working on improving the reliability of the Intuit Kubernetes platform. And in his 15 years at Intuit, he worked on most of the Intuit products and played various roles in the organization, including a developer and an architect. And he's led numerous successful initiatives and innovatives to fruition. So, hello there, Sumit. It's an honor to have you on the panel, and can't wait to pick all of your brains, honestly.
Thank you, Divya. It's an honor to be part of this panel.
Our last panelist for the day is Ramiro, who is one of the founders of Cloudnative. He spent most of his career building cloud services and developer tools. Before starting Cloudnative, though, Ramiro was an architect at London and software engineer at Microsoft Azure. He's originally from Mexico, but he currently lives in San Francisco. So I'm guessing we have like a really diverse panel in terms of the geographical location. And hi, Ramiro, and it's again, pleasure to have all of you guys on board. Based on the discussions that we've had with a lot of the chaos engineering community, we have like a few burning questions that folks have asked us to sort of clarify and have discussions around so that they get more insight into the chaos engineering disciplines. So going forward, these are some of the topics or subtopics that I will be discussing. And my first question would be obviously starting with chaos engineering today versus what it was say around 3-4 years ago when Netflix popularized it, with the chaos monkey and the whole chaos monkey thing back in 2011. So Sylvain, I'd like to hear from you as to, do you believe that it's still a very nascent discipline, or has it seen a sort of evolution in the way people are looking at it?
It's a broad question. It's an interesting one. I think it's more under the radar, under the radar of developers now than it was 4 years ago. I'm not sure that it's interesting because I've seen a lot of large companies getting interest into chaos engineering in general and reliability even more generally. So there is a lot of evaluation of toolings, whether it's open source or commercials. So I think it's still nascent in the sense of it's nowhere near a de facto thing that people have to do and take under. But I guess a lot of projects still don't do properly testing anyway. So it's a long way. But it is. I think the fact that tooling is getting more popular, especially on the Kubernetes land, has helped a lot, whether it's project like Litmus or Chaos Mesh or hopefully humbly Chaos Toolkit a bit. I think that things have improved, but there is still a long way to go because what we're seeing now is, in my opinion, is we're still asking a lot of people to get into the understanding of what chaos engineering is. It might be interesting at some point to shift left and bring chaos engineering to people so that they don't necessarily have to think about it, but they get the best of it. And I don't think that's ready yet. So what we're saying is it's exciting for people who want to get into that. I'm not sure it's necessarily something other people have the time to contemplate. But it's just my little view of the world. I'm not sure that's exactly the reality or not. I'd be interested to hearing everyone else on that.
So I was when in a large enterprise like where I work at, there are plenty of apprehensions and blockers around adoption. Primarily because of the myths that are floating around regarding, the discipline, like, it's just about breaking apps in production, and it's difficult to get a buy-in from the folks at the top, if I can say so nicely. So, anyone on the panel, if you are, if you have faced any apprehensions or blockers for adoption of this particular discipline in your workplace, if anyone's interested about talking about that, that's kind of what we're looking at, because chaos engineering as of now, even though like Sylvan said, it's adopted and there are tools, it's not as widely adopted as we'd like to be. So if anyone on the panel, if there's if you have some thoughts on that, please.
Well, I can weigh in here from NetApp's side. So the management buy-in is quite good on chaos engineering, especially since when I got in to the subject and what I was first. I of course had to sell this as a concept to managers because it is costly, and the benefit for us has definitely been to prove consistency within observability. So more than as a startup point, I did not start out with improving resilience in our product, but improving visibility in our observability stack. It is all good and well to have Grafana running, but if it doesn't really show the state of the system, for example, if I've taken down a certain part or black holed certain pods, that should be visible, or at least the symptoms of those should be visible in both logs and in our charts. And so it was an easy case to make, to show where I could pretty much cripple the system partly, and that the charts wouldn't show it properly. So it was easier to get management buy-in on that part than actually, because it is also a bit terrifying to allow someone to go in and kill the product in a live system, and that is understandable. It's going, so we do have management buy-in, but it's very, very conservative, and naturally it's money. Nobody wants to disrupt their customers' services willingly. So at least for the moment now, it has been the easiest for me to improve visibility, saying that it's to improve observability more than resilience. That was the path that I took. It was the one that I found to be easiest and most visible to show. So I don't know how that is for everyone else, but that is the road I took, and I definitely have management buy-in. But there is time constraint. We are extremely busy, and more so due to the that we are a storage company, and with the incredible amount of data being collected today, we are busier than ever. So there hasn't been a lot of time to go much further into production than this particular part that I have spoken about. So that's what I have, at least.
Yeah, absolutely. Anyone
I
else?
can chime in. Yeah, I can chime in. So there are two models. One model is a push model, like you have management buying, and then they will say that go and implement that. This is one common model, which is a little tough because you have to look for the business priority. There is another model where you are a customer facing application, like Intuit has a many, and there is a natural need that your customer uptime will always be there. They will get a better experience. So that creates a lot of pressure on the products so that they can think about resiliency, they can handle about these kind of chaotic behavior upfront. So we do see both the things. We do try to see if we can push few things, as well as the naturally lot of product teams, they are coming forward and giving their specific scenarios, which is that how we will handle this specific scenario. Do you have a specific chaotic operation on that? In Intuit, I think there are many solutions. We work on that right now. We are focusing on the chaos toolkit with the litmus, but there is a right now I don't see that everyone has adopted, but there are a lot of good hope and good light coming in future.
Okay.
Just to put in a couple of thoughts there, I think Christine made a great point about, I think that's a fantastic part to sort of say that we want to highlight how our observability systems are they really showing the right errors? Are they behaving the right way? I think we're going to use chaos to find out that it's working or not is actually a good way to sort of start that process. One of the real inhibitors, I could say, of chaos, at least in many organizations, at least the up and coming ones, is the fact that they don't have the right observability system in place already in order to achieve chaos, in order to go ahead with chaos engineering. So if you inject chaos and don't know what's happening, then that's a very dark place to be in. So people want to wait until they have got the right infrastructure before they start chaos engineering. And then there's also this concern about, okay, I did chaos, and production can mean different things to different people. Your applications in production, your actual business app in production being used by your end customers is something, but there are a lot of stakeholders, like Sumit mentioned, within your organizations are also treating some part of your infra as production. So they want this big red button which is able to revert your chaos or whatever you set out doing initially. And they also want to be able to control the chaos the way they want, probably. I think sometimes a lot of frameworks already provide that, but there's a need to educate, and sometimes configurations are not easy to make. Let's say when you're setting a timeout for your chaos experiment, what is the config that you're actually setting? What's the time that you're actually doing needs a certain amount of application behavior and know-how before we actually go ahead with that experiment. The hypothesis needs to be there. It takes a little bit of time for folks to actually invest in the time to know those kind of things and then actually do the chaos. So I think that's probably something that people are not able to spend time on, devote that much time to. Like Sylvain said, a lot of people are busy doing a lot of things, and they generally get to chaos after a certain amount of stability is reached with other processes within the organization. So they sort of know about chaos engineering, but they put it on the back burner because there are things they deem more important at that point of time. So I think, yeah, that's one of the thoughts, one of the findings.
Right. So chaos engineering from its inception has kind of now evolved into cloud native chaos engineering. So I just wanted to go around the panel and understand what are the characteristics of cloud native chaos engineering as a category, and what was the exact need for this kind of subcategorization. I think I'd like to ask you this, Kartik, because I believe it was in 2019 that a blog post had come out. I'm not sure which was the month or whatever, but there's a blog post by Uma from Maya Data regarding cloud native chaos engineering. So if you could please shed some light on that.
Sure. Yeah, so we did sort of formalize that or crystallize our thoughts in that blog that we sent out in CNCF in 2019, like you mentioned, but the seeds of that were already sown a little earlier. In fact, there was a chaos engineering work group that was initiated by Sylvain in KubeCon, I think in 2018, where he talked about cloud native chaos engineering in the actual CNCF forum. And that work group, we were all a part of it for some time before it sort of merged into other SIGs within CNCF. So one of the things about cloud native, the word itself, cloud native, I think at face value, literally you can just see that it's the way applications is built for cloud environment. But it also implies a lot about the approach to building those apps and its characteristics. Typically, for our practical purposes at least, cloud native from the CNCF point of view means your application is built out of several microservices. It's a distributed model. It's all containerized and it is orchestrated via some systems like Kubernetes, and it's using all the best practices such as continuous integration and delivery, and it is using a lot of tools on the CNCF landscape. That's what roughly you would visualize cloud native to be. And when we started Litmus Chaos, I think at that point of time, it started as a need to meet the chaos needs of another project called OpenEBS, which is actually a containerized storage solution. And when we started out with that project, we felt there's a need for us to align with the same operating principles of OpenEBS. OpenEBS runs in Kubernetes. It provides persistent storage, and the users of OpenEBS and Kubernetes in general are used to dealing with all resources in a declarative way. It could be native resources or any custom resources they built for managing or extending Kubernetes to suit their own applications. It was all declarative, it was all reconciled, the actual state was reconciled to desired state. And cloud native really today more or less means Kubernetes native. So it's almost becoming extricable. So we wanted to create something that, and I'm sure that a lot of others would have felt the same need to create something that aligns with the same user experience that people are getting for doing other things on Kubernetes. They want to do the same thing with resiliency and chaos as well. So what started as a chaos testing project for OpenEBS eventually turned into something more generic because we figured it might be useful for other folks. But that's what we wanted to term cloud native. So there are some common attributes of all projects within that cloud native landscape. They're open source for starters. And that means that there is going to be a community around it. The projects themselves and the direction the project takes is going to be community driven. And chaos again is something that's very generic. A lot of people have a similar need. And irrespective of whether you're running stateful applications or stateless applications, or what is the purpose of that application, how you're running it, it still needs reliability as the most important thing, all the 5 nines, 6 nines, etc. And chaos is the way to do it because it's not going to be sufficient doing integration tests and functional tests. So chaos is a real need for a lot of members in the community. So cloud native we defined in the blog, we defined it this way. It has to be open source, it is community driven. and it is extensible. I think Chaos Toolkit also was one of the first projects to create the Open API standard where you can extend experiments based on a certain pattern. You could reuse APIs, build your own custom stuff. Litmus has also been big on being extensible and being able to orchestrate not just native experiments provided by that project, but also experiments created by anyone. We just need to containerize it. So it has to be extensible, and the fact that the APIs has to be clear. So when Kubernetes APIs are probably the most popular ones, so we just lent ourselves into that model, just create custom resources because CRDs are APIs. So these are the characteristics we felt were really cloud native. Before that, what was there? Chaos Monkey from Netflix or anything else that was there, or they were projects that were already serving the needs of Chaos on containers, but not specifically for Kubernetes. So that's when we define this category. And whenever you define any subcategory, it means you're taking note of operating characteristics specific to that area. And you tend to look deeply at the problems that are there in that particular area. So Kubernetes it's a beast, right? It's an orchestration system that's very complex, very dense. And a lot of people want to get into Kubernetes, but they're not really sure whether they should go to production on Kubernetes because they have to re-architect their apps. They might have lived for decades on legacy systems. So Chaos is a way to help them slay those apprehensions, but at the same time use an approach that's very Kubernetes native. Help them be more Kubernetes centric while they're doing the resiliency testing. That's what we really looked at, and we created this category called Cloud Native Chaos Engineering.
I think that was really insightful. Anybody on the panel has a big chip in addition to what Kartik has said from their experiences on the project?
Yeah, I would like to extend on that kind of from the other side, from the side of kind of like the developer building cloud native applications. I think that it was very it was a good time for this concept of cloud native chaos engineering to come up, because you know, as well, this now that Kubernetes is more prevalent, it's accelerating a lot of patterns that were, you know, microservices, serverless. Those were things that were being adopted before, but with Kubernetes, it just became faster. And as this happened, we all started to realize that our applications are, if you don't do anything, your app is going to be more brittle, it's not going to be reliable. And a lot of people kind of like got into this, and I've seen this with our customers or ourselves, where you get into a point where like, okay, now I understand why chaos engineering matters, because if I don't do it, my app is going to be chaotic anyway. Like pods get restarted, and nobody really thought about that before. And with VMs, it was not a concern that every day your pod might be restarted the way it's with Kubernetes. So that's where I feel like it's these two things where the community was already thinking about chaos engineering, saw this topic, then the user base were like, yes, we need this right now, because now we have this orchestration. Now the orchestration is something more mainstream. Apps are going to be failing. I need to understand how they're failing and how to prevent it. So I'm really glad to see this kind of like two words come at the same time. And I feel that's one of the reasons why we're seeing a lot more adoption on the chaos community compared to, you know, before, where you had Netflix really pushing for Chaos Monkey, but it was to a certain degree more of an academic, like very high level approach. Most companies were not really adopting it. And now with Kubernetes and, you know, Chaos Toolkit, Litmus, Chaos IQ, and others, I think now we're seeing a lot of more organic adoption, just because people really understand the problem. They really understand why it matters. And especially, you know, testing has always been something hard to sell to management and hard to sell upstream, right? It's like you invest time on features or testing them. And most companies would rather put out more features. But I think now we're seeing a lot of companies realizing that if you don't invest in something like chaos engineering, then your apps are going to be failing all the time. And now that they're distributed by nature, they're going to be really unresilient. And now that becomes a very strong motivation for either top down or bottoms up to really appreciate and invest in things like chaos engineering, which for me is great, because I have a test. I used to be a Q engineer, all those things, and it was always hard to sell these things. So I'm really glad that now it's becoming more of a, yeah, we all understand, let's put in the priorities and balance them. And that's something that I think the cloud native world is doing very, very well.
What, just if I may, one thing that I found very fascinating on that is what we've seen, at least from the Chaos Toolkit side, is people come and say, but what should we chaos about? Where do we start, right? What is the right experiment for me? And it reminded me of when I was a long time ago, probably too long, a performance tester where, I would load test and performance test some internal applications at a retailer. And people from a program would come and say, can you performance test? And say, yeah, of course, but tell me, what are you interested to learn? And people were shocked about the question, because to them, I was the expert. Yes, I'm the expert to run the tool, but I don't know anything about your application. So you need to come up with hypotheses. And that's what we unearthed with resiliency, reliability, and chaos engineering, all those, all that lot is, you realize most people, at upper management or actually probably, upper management more than anything else, but you see a variety of people just figuring, looking at you puzzled. What do you mean I should know about the problem my application could have? And it's fascinating to see their thinking, because they realize, well, actually, I don't know anything. I don't know what's going to happen if it fails. I don't know if I can actually handle it. I don't know if sometimes, for large application organization, you could go as far as, do I even have a PR department knowing that if half of my application goes down, I've got someone who knows what message to put out as quickly as possible? Because today, as I often say, which is fairly true, your first alert mechanism is not your observability, although it's, and Tracy, you're right, it's actually a fantastic idea to run chaos engineering for that. I fully agree on that. But your first line of understanding what something is going wrong is Twitter or some other places, because your users are usually the first to know that it doesn't work. And I think you're doing a great job at saying we need to be better and more proactive at learning those things. You're completely right about that. But that's so interesting, because while people have now, they feel the power of those platforms like Kubernetes and everything, they feel even less knowledgeable, if you will, because the abstraction is so big, like you said, Trick, it's a beast, right? Kubernetes is a beast. And more often than not, you're probably using it when you don't need it actually in the first place, but you don't realize that. And I think chaos engineering is fantastic for that, because it's one of the tools where you say, okay, I'm going to explore. Now the priming, come back to what you said, Christine, is lack of time. It's lack of time, lack of resources, lack of, okay, give me a moment to actually go and explore. No, we need more feature. We need all those, the usual. But it's still fascinating from a philosophical perspective to realize when you see someone at management and say, well, I have no idea. I don't know what's going to happen if it fails. And just to finish on that, once I did a chaos engineering meetup in Paris, and we were at a company, and mostly developers were there. But the first person who came in and asked a question was the CTO of the place, and said, can I chaos engineering, create a chaos engineering experiment that figures that one of my data center has gone down? That was a level for that CTO of worry, right? And Chaos Toolkit can do a lot of things, but I'm not sure we can figure out a full data center going down. But it was interesting because that person came and said, that is a worry, and that happened because 2 or 3 months before, a large cloud provider in France had, and that is rare event, but 2 of their data centers in 1 week going down for different reasons. And the thing you'd think that can't happen did happen. And all of a sudden, a lot of CTOs and other VPs in France were like, well, okay, if it happens, I need to know what can I do about it. So yeah, I think it's fascinating, because the more power we have on one end, the less powerful in a sense we feel about, we control. And serverless is even almost worse, because yes, you don't control anything. Yes, you don't control anything. Anyway, sorry.
So
I have an idea on this one as well. It's one of the things actually which I didn't think of when we started out with chaos engineering, which I found was extremely useful, is the fact that we had to start to define what is the healthy state of our applications. No one had ever done that. just the fact that they're up and running doesn't necessarily mean that they're healthy. And I think that was one of the greatest benefits that we have come out of this, which really was sort of a side effect more than anything else. We had to define the healthy state. I think that was extremely useful, at least for us.
Yeah, just to tap on what Sylvain said, right? I think if I remember correctly, Sylvain Russ came to Intuit in 2016-17 time, and we had some meetup of chaos engineering. That's how I came to know about that. And during that time, there were a lot of interest was there on resiliency, chaos monkey. But in Intuit, there is a very interesting thing that whenever we have an incident, we do the RCA, and that actually gives that where and what we need to work. And availability should be a top notch. Like we cannot have the site going down or data center going down. So availability is really, really important. With the availability, we want customer to be served in the right manner with the right user experience. So that means reliability of that thing is important. So that creates a lot of pressure on the application as well as the services, that how they can render, how they can serve that. Now with CNC, cloud native chaos engineering coming, all the paradigm of monolith is changed. Now from existing monolith being hosted in an AWS, it becomes small containers. Now those containers need to be validated. Those containers will host in a Kubernetes. That platform need to be validated. That platform is sitting on the cloud, which is AWS, that also need to be validated. So now you have so many other combination permutation available, where earlier you used to only validate that my uptime is there, or I'm able to render the content correctly or not. So it created lot of options, and adoption of chaos engineering is one of the reason, because how you can do all those things. It's not just a chaos monkey that you go and just kill a EC2 instance. You have to think about the holistically, that how you can certify this platform. Right now, I've been doing something similar to that, because in Intuit, we are using this platform. We're hosting hundreds of clusters and thousands of services. How we can give a guarantee to our customer that when they come to this platform, apart from application, they will be able to get reliability out of that. And again, I've been using Chaos Toolkit for long, and Litmus has given a way that you bring your own framework, and that's how the important thing I think everyone's mentioned is that the use cases, how you build the use cases. You build the use cases and then you attach that. Now if you go for some other framework, there is a very, very the choices you have to make, that whether you adopt a new framework or not. Litmus and Chaos Toolkit, I think that was a natural way of what you call the merger of cloud native chaos engineering. And I love that. I think it's just a couple of months that it was up and running. So
absolutely. So I was actually listening to all of you guys, and given that, given the evolution from CE to CNC, what has kind of struck me, as I have actually spoken to a lot of folks in the community, is that earlier on it was, a sort of or infrastructure engineering or an SRE's responsibility. So so any chaos experiment needs to be done. Hey, let's push it on the guy who's actually dealing with the reliability bit, because it's his responsibility. So has that evolved at all, or if it has it gotten a buy-in from the other sides of the organization, like from developers' perspective? Has it become a thing to become more involved in gameplays and experiments altogether? So that was the kind of question I had personally, because earlier on, when I was reading through all the books, most of the stuff that is mentioned in the book is that hey, it's like this is a specific thing that needs to be performed by the specific person, but has it changed at all in the industry? Kristen, if or whoever is actually there to answer. Yeah.
I've seen a lot of change, and I think that's, you know, our company, we deal with developers, they've experienced, so we really focus on what Sylvain said early on this shift left of moving things from, you know, before testing chaos resilience was seen as something that you kind of like validated before shipping. It was like, you write your code, then you do QA, then you do resilience, and then you're done. Now, I think everyone understands that it's not something, just like security, you can't just put it at the end. You can just make your things resilient at the end. But I think that's kind of understanding in the industry, and is very visible when you see your applications, you know, failing. So I think there's a big shift. And I think what Kartik was saying before, by having, you know, Kubernetes becoming kind of the standard for orchestration, all these APIs that now, you know, Chaos Toolkit, Litmus, they use the same APIs. It makes it a lot easier for developers to just run this as part of their normal cycle. Like for us, this has been a push we've been doing. A lot of our early adopters is this idea that all of this testing, quality, chaos engineering doesn't have to wait until the end. Like the earlier you involve, just like anything else, it's this continuous integration kind of mentality where you're adding it from the very beginning, and it's easier to fix things the closer you are kind of to the source. So we're seeing that a lot. We're seeing a lot of developers getting it, getting more involved with this. Even from when they're designing applications, we're bug fixing. You know, once you start talking about like, what does a healthy state look like? What's your hypothesis? Developers are in a really good position to answer these questions, far better sometimes that, you know, that the more dedicated performance or quality engineers, if you work in kind of those divisions. So it's something very exciting. I think that this junction of Kubernetes, common APIs, and cloud native chaos engineering is really becoming a catalyzer for from one side, making all of this more mainstream, and also having more people take ownership, really see the value, and then start to apply it a lot earlier than what traditionally we saw this kind of a tasks being done on the software lifecycle.
Another point I think is, just to build on what Ramiro just said, the SRE role also has evolved quite a bit. I think there's a lot of porous boundaries between DevOps engineer and an SRE, and some organizations people develop in different roles. So everyone is a developer of some type. Could be an application developer who is doing the actual business logic app, somebody is doing an infrastructure developer, things like that. In fact, one of the things that we've noticed over the last few months, or you can say over an extended period of time, 6 months to 1 year, is that there are a lot of developers who are actually trying out chaos, and the adoption of chaos experiments in CI/CD pipelines is probably on the rise, really. There are a lot of people doing it in a traditional way. So I think this is also ties to our earlier question, like how has chaos engineering evolved over a period of time. One of the aspects is that there are a lot of people taking up to taking chaos engineering up much earlier in the cycle. They don't want to wait till the end. There are developers who are doing it. Let's say there are chaos experiments being done in dev test, if that really makes any sense. So there are people who, even before they get into what they think as staging and pre-prod environments with the actual, they don't even have setups that is mimicking the real production, but they're doing it on clusters which are coming at a much earlier stage, because that itself can give you a lot of insights into how your system is behaving. So then you can ask the question, how is it really different from failure testing that people are generally doing? So the take on that is, chaos engineering in some ways, at least with cloud native chaos engineering, I think is also encompassing that. Failure testing can be seen as coming under that, or the other way around. The only difference being, I think in testing, people are interested in how of things. They really want to know the functionality. But with chaos engineering, it is always about what. So you might have defined some kind of end application behavior, which is so difficult to find, so difficult to really gauge what is the real steady state. It could be some metric, or it could be some such thing. They have that in mind. And when they do these experiments, they're looking at what's happening to that. How much of a deviation is there in that. So a lot of things like mean time to recovery and other things can be found earlier, they might change, the behavior might really change when you move those applications into a larger system. There are so many other factors that come into play. But I think that left shift is definitely happening, and there's an uptick in the number of people doing chaos at that stage. There will be some conservation around doing it in production, testing in production, and doing it on a large scale, but there are a lot of people adopting it at the earlier stages. So in fact, that's also helping people in adopting chaos engineering.
I wonder, the one worry I have with that shift is developers, which I feel I am. I've been a developer for my life, so I'm counting, myself into what I'm going to say, but are extremely conservative and sometimes, difficult to deal with, because they want things that don't necessarily, they are quite binary. So it runs or it doesn't run. And there are so many signals now in any CI/CD pipeline or GitOps pipeline, actually, to make it a little more cloud native, that I can appreciate the feeling of too much signals, right? My tests are failing, my this or that are failing, and what I hope is by shifting left, which I think is a good thing, because the sooner you get something, the less costly it becomes. If like Ramiro was saying, if you wait until the very end, it's going to cost a lot. I was in a company where the QA sometimes happened like 6 months after the development of something happened. And when QA raised a bug, they were doing that in good faith. The developers were very unhappy because to them, the context had switched completely. They couldn't come back. So I think it's a good thing, but at the same time, I don't want to lose the creativity of exploring. I don't want, well, I don't know. Hope we have a balance between the two, so that we are able to still, have some people saying, well, to me, chaos engineering is asking a lot of questions, right? And as soon as you start to standardize too much into a pipeline, you don't really have room for what it may or may not work, right? In the sense of, I don't really know, let's go and see what's happening. I think it's good if we still have teams or people or whoever, depends on the engineering team, but that an understanding that it's not enough to run your experiments. Even if you run that every day, you still have to be creative about, what else could become a problem? What else could we explore? What else could be a problem we haven't thought about? Because if you lose that by making it too automated, which I think you need both, but if you make it automated, then sometimes it's a bit rigid, right? And chaos engineering, to me, is a lot of creativity around what could go wrong. So yeah, that's that. I hope we don't lose that mindset, because to me, it's quite important as well for getting the most of it. Even though more automation means sooner, means cheaper, means, obviously a great outcome. So I think if we find that balance, I think we could have a very powerful, tool. Otherwise, it's going to become another form of rigid, framework that sometimes people will turn off because too many notifications.
Yeah, unless you're
right.
Production is
Right. So I totally agree what Ramiro, Sylvan, and Kartik said. We actually started doing shifting left quite a bit a couple of years back, and we figured it out that is one part, but the important part is that how you can do the self-serve to the developer, how you can make everything infra as a code, how you can implement GitOps principle, how come you can get everything in a pipeline. Because if the code is not coming in pipeline, if pipeline is not validating, as I think someone mentioned, that a 6 month, right? So the waterfall words are gone. There is no more waterfall word, right? So you have to everything be in a part of pipeline. To have everything in part of pipeline, you need to adopt the latest and greatest, which means that if you are going on GitOps model, if you are going on a cloud native, how you can put everything, wrap it up around the infra as a code, and then you can use the nitty-gritties of all the tooling available in the chaos engineering and wrap it up as part of pipeline.
We actually have also, shifting a little bit away from the conversation, I just thought I'd grab the opportunity for one, which we haven't started to implement, but it was an idea we had, was to use chaos engineering for SRE training. Now, there are few ways to learn, or the way of learning how a system works for an SRE, if you're shifting away from the development, because the developers usually know the core, but not necessarily very familiar with what happens once the product has been deployed. Often enough, they don't even care. So what we had an idea was, what is better than to take a system, cripple it, and let our new hire fix it? I just thought that was an interesting sort of aspect of chaos engineering, which we haven't started, actually, we haven't used it, but I'd like to try it out, because I know, at least for myself, when it comes to learning, not only as a developer is learning the system, but as an SRE who is supposed to take an application and is supposed to perhaps answer a phone call at 3:30 in the morning, it is very, very nice if you sort of already have it in muscle memory. What's the first place I go? What's the word for it to look? What is the Grafana chart I'm supposed to look at? Where are the logs, which are likely? And what better way to train someone than have a system that has been chaosed to the, and even better, chaosed, reflecting a state that has already happened. So save your tickets, save your Jira, save your I don't know, detailed dissections of certain problems, and then recreate them using chaos engineering as a robot, even an AI, if you will. And then let your SRE, your human, fix it. I mean, supposedly there will also be, the self-healing is supposed to do it. But if you've set up a system in such a state that somebody gets a phone call at 3 o'clock in the morning, then that they have been trained and actually have already experienced this, maybe not only once, maybe twice, even 3 times before, makes life easier for everyone, especially in those cases, because not all problems, and I completely agree with Sylvain on this, not everything is, there's still the human factor in all the systems. You can't rely on everything being precise and robotic and mathematically correct. If A happens, then you have to do B. So I'm going to create an experiment C. There is a bit of, art in this, if you will. And I think it's important to keep that part, because if you create a rigid system with rigid experiments, and then the errors are far from rigid. The errors are often very, very, very human. I have a case here from Iceland. We are a small country, and I used to work for the Icelandic Bank's data center a few years ago, and they had 2 completely separate server rooms. And what happened is that in one of the roads here in Iceland, they were digging, and one of the guys saw a cable that was in the way. He just cut it, and then it could finish digging, but it took down one of our data centers. It's, it creates sort of, it is hard to, of course, replicate a system like that, but that was a 100% human error. And you have to keep this in mind when you're creating your chaos and your experiments, that not all errors are because, I don't know, the disk is full. My personal nemesis is either full disks or expired certificates. Not everything is, in 99% usually are, but there is that really, really, really important 1%, which we need to keep open and human, in my opinion, my humble opinion.
I love the idea. I used to suggest to Russ to say, we need to actually onboard through chaos engineering. What a better way to actually learn and say, when you arrive, say, you shouldn't fear the system. So we're going to actually, do some harm to it, and you're going to see that it's okay. And I think it's a fun, yeah, but you're completely right. I think it's fantastic. The human factor is so important. So keeping that balance between that factor and the automation, which is always helpful, is probably going to be one of the challenge of, the future of chaos engineering.
Just along with the human aspect, I think extreme that having the right kind of documenting your stuff, maybe it's sort of, that's one of the things that is generally underplayed. A lot of times during chaos experiments, when done, in the way that we just describing, can throw up a lot of information which needs to be captured. I think there are GIMD templates available today where people have a lot of reports that they take down, a lot of information that they store. I think that part of it is extremely important, the process part of it, documentation part of it. So when people have the right idea when they're sort of seeing some behavior the next time like that, or when they're crafting their next experiment, they have really the right information on the base upon which they can do that stuff. So yeah, that's probably, you can do all the automation, but still the human factor is really important in writing down the right perspective, understanding the hypothesis, understanding the results that actually happen. I think that part which is still really important. I also completely agree with the panelists.
So I was very, interested, and one of the next questions actually was about chaos engineering and CI/CD pipeline. So I think Sumit, you already have a talk about this in KubeCon NA, which is coming up, and I'm pretty excited to see that. But how is it implemented in CI/CD pipelines, and could you shed a bit of light on that?
Yeah, sure. So as I mentioned that if you want developer to adopt, you have to think about self-service. We already talked about shift left, so that you have to bring everything early in the cycle. Now, when you are in a cloud native, the thing is that you need to go as close to your infrastructure or your Kubernetes cluster. So what we have done, which is I think pretty generic for anyone to adopt, is that we use another CNCF project, Argo, and we attach the Argo to orchestrate this chaos experiment. So in Chaos Toolkit, you can go and you can run one experiment. If you go in Litmus, you can go and run one custom resource. Now, what we have done is that we have taken the goodies of Chaos Toolkit, all the scenarios, we package it in the Litmus, and then we wrap it up in the Argo. So now, as part of the CI/CD, all your tests, which is more about your application, your platform, and your cloud, they all can be orchestrated via our simple Jenkins job. And that is the biggest value add, because now for every team, this pipeline is there. And good thing about chaos engineering is that it is not the same how performance or other functional testing. 50% of this catalog is already available. You wanted to kill a pod, you wanted to kill application, you wanted to kill a EC2, you wanted to kill the specific service. So most of the catalog is available. Now, the only thing is that your specific scenario you need to add. So most of the pipeline, 50% scenario is available. And as you go and add as a shift left, you will start finding the problems as early in the cycle. And GitOps is something which is very, very recently we have worked on that. We use Argo CD for GitOps. So this whole thing, if you think about that, you have 5 teams and 3 teams say that I wanted to do that, and 2 teams say that we are not ready. How you handle that? Because now you say that you created a payload for every team. They will come here and they will get this pipeline. Now, how you can do that? So for that, we introduce another concept called GitOps, where you say that I want this experiment, I don't want experiment, and pipeline will continue running. If you don't have, you can ignore. If you have, it will go and execute. So that it's more towards that when you are ready. When you are ready, you use it. When you are not ready, you say that we'll wait.
So a follow-up question to this actually. So when we are performing chaos or the CI/CD pipeline, is it more like from an engineer's perspective? Is it chaos engineering at all, or is it like more of failure testing or something of that sort? Because what are exactly the needs when they perform chaos engineering on a CI pipeline? With respect to say an application or your pod or something, you have specific needs, but in case of a CI pipeline, what are the needs of the engineer supporting it or administrating it when they perform chaos on that particular pipeline?
So I think someone mentioned that we still need a human element, but we need to try to see that we can do as much as automated. Chaos toolkit, as well as any chaos engineering principle, they have a basic concept of hypothesis, the pre-hypothesis and the post-hypothesis, and you do action. And that is the core part. But there are still some time when you are doing pre and post and we are doing action, there is some time where the system will be in the state you wanted to know that. So we introduced like continuous performance testing or continuous testing during that time to ensure that when pre and post hypothesis met, before that, what would be the state? Because we want the customer FCIs, which is fail customer interaction, to be 0. How that could happen? If you continuously do the observability for your CI/CD pipeline. And we have actually already implemented, and we will talk about that in KubeCon.
I think.
Sorry, please go ahead. I'm so sorry.
Sorry, if I may. One thing that it's good you made the distinction between failure injection and chaos engineering here, because one of the downside of chaos engineering, it's its name. It's misinterpreted for breaking, and which is, you know, it has an edge, you know, it's very cool and very trendy, but it's harmful to the idea. First of all, because people who haven't followed say, well, what are you going to break? Why do you want to break something? So I think it's been a little harmful, and quite often what we see is fault injection. I'm going to inject a fault, which is great, but you don't have to inject a fault to learn. In fact, you really have a lot of scenarios where you can mimic some of the, for example, of the human factor we were talking about. I'm gonna give an example. You're on your Kubernetes and you have two services talking to each other. And all of a sudden someone somewhere decided, for probably very good reasons, I'm not, you know, judging that, but to add network policies. And all of a sudden those two services can talk to each other, right? Now that's, I guess it's a human factor in the same sense that someone cut the cable instead of cutting a cable is probably rerouted the cables to nowhere. A fault injection is going to always have that idea that I'm going to see how the system reacts under stress or whatever. But you realize a lot of issues that people have are not related to that, like Christian said, or they are, but they are not the only ones. A lot of things are configuration issues. Configuration, you know, or changing the system, adding a network policy, or if you're on AWS 3, someone changed the credentials to write on the bucket, right? What happens? It's a domino effect. So I think it's interesting to, if you remove yourself from fault injection and really think in terms of chaos engineering, in terms of, well, you know, what am I going to learn today about my system when it does something? Then it's very nice, because sometimes you can actually mimic the human factor. In that case, for example, you can just, you know, automate and pretend those network policies arrive, and you have an experiment of yourself. So I think injecting faults can be reducing of what the whole philosophy is all about. So it's important to, it's not distinguish, I don't want to be pedantic about it, but sometimes it's reducing if you think too much about, I'm going to stress this, I'm going to change the network, and that. It's extremely valuable. But for example, I'd rather not think about, I'm going to change the network, but more about, you know, what happens if I get slower? It's the same thing, right? If two services, if there is a latency, what happens? But maybe in that case, maybe you're going to think about, you know, you have various levels. You probably have, from an engineering perspective, do I see an error somewhere happening? As Christine said, you know, do I get an alert somewhere on my observability tool? From a business perspective, is I'm actually selling less because now the system is a little bit slower. So those different angles, and you don't want to think in terms of network injection fault. It's just a tool, it's a mechanic. How do you get that information is the most important thing. So that's why it's sometimes it's annoying when it's all about fault injection, because it's just, honestly, it doesn't really matter how you get there. The important thing is that the information you're trying to get overall. anyway.
I 100% agree there. There are two things which are this is really, really hard to do without chaos engineering. I think chaos engineering per se, exactly, to make this distinction between fault injection and actually causing a real life scenario that QA and standard testing cannot do. And one of those is cascading failures. Again, because one little service is starting to respond slower, another one is taking on, and then the third one just cannot handle it, and then you have this cascade of failures. I think chaos engineering is extremely valuable there. And the other one is customer-induced retry storms. That's the human issue, which is really, really hard to simulate, but is so very important to realize what does the human behind on the other side of your system, how do they respond, and how can they actually potentially make situations worse simply because they're human beings. So I agree with this. It's not just fault injections, there's so much more than that.
That's a great point. I think one of the principles of chaos also is the fact that you have to have a proper hypothesis. I think that's what maybe separates, that's very subtle difference between failure injections or fault injections and then actually doing chaos experiments. You learn about the system, go with some kind of an understanding of this is what the system might behave like. And we have these concepts of known knowns and known unknowns and unknown unknowns and things like that. But have a fair idea of how a system might behave in a certain fashion, but you don't know when you extend that to the next level of failure. And like misfortune doesn't come singly, right? So you might have a bad node. Might have a node which is already exhausted in terms of resources, and then you have a part failure happening elsewhere on some other node. So you're not in a good position to schedule that anywhere. So these kind of things, the ability to create complex scenarios, I think there are, one is the human aspect, trying to mimic the human behavior and trying to construct these chain failure kind of scenarios. And the other aspect is to have the system be capable of executing that kind of change scenarios. I think as chaos engineering frameworks, and that onus is there to give, is on us or gently the community to provide that kind of an ability to SREs to be able to construct those kind of scenarios and sort of execute them. And I think hypothesis here, in the case of these kind of change scenarios or multiple component failures, what are we really looking at? What are we trying to learn from the system? To be able to define that and to be able to actually get that information back to the SRE or the developer who is running those experiments is really important. And I think that's sort of one of the things that we can tie to this evolution as chaos engineering is evolving and as a lot of frameworks are coming in and as they are evolving. One of the things that would be of real value is to be able to help do these kind of complex scenarios and bring back information that's relevant to them. And then what can be delivered from then on is probably left to the executor of the experiment. And this, and to sort of map this analogy and to just get a little bit philosophical, in quantum physics, there's a lot of emphasis on the experimenter. The guy who is running, or the person who is running the experiment, is probably as much a part of the experiment as the experiment itself, if you get what I'm trying to say. The perspective really matters. So to get the information back to that user, to be able to help him to construct those complex scenarios, I think that's one direction where I think chaos engineering is headed in terms of practice and frameworks.
I can share one very interesting observation as we just touched base on that. Especially on the Kubernetes or AWS, when we are behind your application and you have load balancer and everything exposed to route or gateway, you kill a pod and the live traffic is there. And if your application is not able to handle the SIG term, there is a problem. You will get a 502s. If node has been deleted, you will get 504. So how you can ensure your application is resilient to handle those 502s and 504 is something you will get only when you do all those things upfront. Otherwise, one fine day when you do it, You get world-class cloud, you get world-class infrastructure of Kubernetes, and regular maintenance happen, and pod rotated, node rotated, and zoop, you have 500, which no one wants.
Yeah, I wanted to add something that Kartik was saying too that kind of came to me, which is the experimenter being part of the experiment. It's an interesting topic and it makes sense. And I think that's one thing where frameworks, especially modern frameworks, are doing a really good job at making it, more accessible to more people. Because I found that, when you only have one type of person doing your chaos experiments, if only your developers are doing chaos experiments, they're gonna tend to test the same few things. The same way if you have the SREs doing it. So something I really like about particularly Litmus is now they have this portal, this very UI friendly self-service. It allows you to involve other types of personas into just chaos testing. And if you can do something like, involving your designers, your PMs, your stakeholders, even, customers of some sort, I think you can get to a position where you're validating a lot of different scenarios. And that's what you're really doing, this more holistic testing. Because as an engineer, I'm going to think of, oh yeah, what if my process doesn't start? Okay, great. But I only care about that. Maybe as I was saying, from a CTO perspective, I'm like, what if the data center collapses? And from somebody else's, right? From I don't know if you have someone from the financial team, they might say, well, what if the API to the bank is down and we can't record a transaction? And that's something I've started to see, not as much as I would like, but I think there's a trend in that direction of making all these tools more self-service, more depending less. And I think that's kind of an inheritance of all this manifest-driven world we're living in, where there's less dependency on a developer executing something and more on like, I can go click here. I have a dashboard. I understand my metrics. I can see the results of the experiment. I can try different things that I like a lot about this new generation of chaos toolkit. And I think that's something that can really help bring the discipline forward and really make it a team effort and not just something that lives like on a corner of a phase of the life cycle or just with one class of people. And I think what you said, Kartik, on who makes experiment is part of it, I think makes a lot of sense. And it ties up to all this conversation on diversity in tech, that we have these people with different backgrounds, different ways of thinking to kind of participate. And this, I think it's a good chance to also get them involved in this process and not just on feature design or coding or validation at the end, and bring more of a customer first mentality, which is really what should matter at the end.
Please go ahead.
One thing on, sorry to interrupt you. One thing on that, much more down to earth, I guess. When we started the Chaos Toolkit, we started to talk to AWS. And in my mind, it was clear that if you're an AWS user, you want to turn around to AWS, I'm sure it works for anyone else, and say, well, you're giving me an SLA, you're giving me like marketing, work, words saying you can be resilient to X or Y, but do you have any evidence to share with me? And in my opinion, we should feel entitled to turn back to our providers of any services and say, can you give me an experiment of when you fail? And that falls into what you folks have just said is, in respecting cloud native, you're not just one team. Everyone is your team. You're backing on your foundation is AWS, GCP, or whoever, and they proclaim, a lot of, and you can probably trust them to do it extremely good, but still, you really want to turn around and say, well, okay, but give me proof, or at least give me the tooling to simulate those failures in some respect, because I have to actually trust your word. And basically the SLA says, the only thing we have contractualized that if you can't respect your word, then I can, you've got 4 hours or whatever, those number of hours. But instead of building, it's not fear, but a legal response, why can't we build trust and confidence that you're going to give me the tooling to harness the, and try your system to the core, so that I can see if my application, my system reacts well to that, or at least give me evidence. We have status pages. I'm not interested in how you're doing or how you failed. tell me what you're doing to actually try that, give me a status page of chaos engineering experiments you're running. That's much more interesting to me because I see what you're doing right now. The status page, otherwise, yeah, it's red. Well, of course it's red because I'm here and I know it's red because it doesn't work. So it's kind of pointless.
I had this, sort of question from Kartik's statement, like he mentioned the quantum physics analogy wherein the experiment is the person actually doing the experiment is as important as the experiment itself. And honestly, experiments and the person doing the experiment wouldn't really benefit in a chaos context without any sort of metrics or any sort of observable data. So what exactly would you as a panel think are the best practices with respect to observability? And you could probably have some around alerting or monitoring, notifications, all of that combined together. If y'all could shed some insight.
Yeah, I'll probably just take a stab at that. Observability, again, is a very broad area and it has a lot of facets to it. Metrics definitely is one, and there are some amazing systems out there in the CNCF landscape. All of us use Prometheus, and there are so many other tools. To give you observability is about what's going on during the experiment, then and there, how your app is behaving is also observability. Observability is also about insights that you are able to derive after you've sort of done those experiments as well. That's where all this analytics and other stuff comes in. Ultimately, chaos engineering is something that you're doing to increase the reliability of your system. So there should be a concrete way. And again, this is something that's going to be very subjective from organization to organization, experimenter to experimenter as to how he treats his experiments results or how he interprets it. But again, the end goal, like Ramiro said, it's customer success. And then there are some known end metrics that are going to be the final statement. Are you available or are you not available? And the service is always there or no, things like that. So to that end, to be able to derive information, to associate some kind of score against your practices or your experiments, to say that this is what you're doing. Quantifying that is difficult, but you can get around doing it with some amount of assumptions, depending upon what really you think are the important elements that are supposed to be ticked. And to be able to see how that score is changing over a period of time, I think that's very important. So what's happening as you do the experiment is how your this 4 golden signals that the Google SRE book talks about, your error rate, your latencies, etc. That's really important. At the same time, what's happening to your system over a period of time, because you might have improved your deployment practices, or you might have gone back and worked on an application business logic to make it more resilient, but have built a chain to the app, things like this. So how it's changing over a period of time, I think, is also observability. And then, of course, the traditional incident response system, how good it is. I heard Christine talk about it, and also Sylvain refer to it. The processes around how you respond to failures when they actually happen. I think that's also pretty important. So you need to have the right alerting infrastructure. You should have your chaos experiment infrastructure to be able to alert you in the right manner and at the right levels of escalations. That's where all the traditional warning, critical info kind of stuff comes in. So that's also part of observability. So metrics, yes. Alerts, yes, reports and analytics and visualization over a period of time to understand how your system is behaving is also observability, yes. And there's also a new component there. Tracing is also an important feature of observability. It's being counted under the telemetry nowadays. So there's some interesting articles out there on the internet about how tracing with chaos engineering. So that's a very interesting perspective, especially when it comes to the dev persona. So yeah, I think observability is really important, hand in hand, and I would say a prerequisite for chaos engineering. And you should definitely not attempt chaos engineering in production or anything that you deem to call your production without observability.
I think I'd like
thoughts,
to.
please? Yeah.
Sorry, Christine. You started by saying that it enabled observability in your organization. So I'd be interested to hear what you achieved, where you started and where you ended through chaos engineering on that.
So well, we're not ended. I don't think that's ever going to happen. But the start was essentially we had a lot of really nice Grafana charts, but our SREs, first thing we did was logging into the pod and taking the logs anyway. Then why have all these shiny graphs if you still have to chase the, I mean, one of the difficulties with, because I come from the old ops world, right? I come from the old world where there was, I mean, I knew the server like my baby. It even had like a personal name, and I knew where it existed. I went to visit it every now and then. You know, it was a physical entity that I personally took care of, and I cared for very much. And it all morphed into and then it of course made sense. You logged onto the server and you checked the logs to find out what was wrong, and observability mattered. I'm not saying it didn't matter, but it didn't matter, especially when it came into trying to find out what was wrong. You needed the logs. To have to do that in the same way with pods and with a distributed system is incredibly time consuming and difficult. So for us, at least at the starting point, it was to get out to see, okay, if I have a cluster of 3 pods, 2 of them go down, is it actually visible anywhere that 2 of them went down? Or even though my service is up and running, we maybe, in some cases, maybe say, oh, okay, the pods have restarted 250 times in the last 24 hours. There's nothing in the observability stack, among them the logs and the metrics, that actually showed this, which means then we have to go in and start tailing logs to figure out why did they restart so many times. So these are things that we have been working on improving. Mostly they're low-hanging fruit. They are unintrusive. It's easy to sell as a concept, and it's because chaos engineering, as you say, it doesn't make sense to inject chaos in unless there is a point to it. So if I have 3 pods running and I kill all 3 of pods, yes, the system is not going to respond. I don't need chaos engineering to tell me this, So it has to be applied where it makes sense, and to show it out in observability, especially to be able to perhaps remove long time-consuming log tailing from a myriad of pods. This is where we started out, but we are still fully immersed in this. We are nowhere near finished, and one of them is, again, and this is a very common, and there's no way that we're the only ones facing this, and I know this from it's the sheer amount of data that you get out from chaos engineering to find, in the forest, to find the tree in the forest, what is actually important. And this is where we are right now, trying to sort out to diminish the noise. I was at a conference a few years ago in London about Apache Kafka, which is highly available system streaming platform, and they used the term sleep-driven design, and I always like that, and I keep on using this. So design your system so that the people who are running it can sleep in peace, right? And I found that this would be one of those things that would help out with it. And not only would, perhaps you have to get up out of bed at 3 o'clock in the morning to look at something, but if your observability stack will immediately tell you, pretty much with a red arrow, hey, go look here, then that person can go back to sleep, or even doesn't need to be called out. So this is where we are at the moment. And also when it comes to this, pipelining your stack, like having your Grafana charts all coded so that you make a change in your chart and you GitOps it, you pipeline it, and then you test your changes in Grafana itself. That is also important. It's not a separate application. It's part of the DNA of the system. I think that's, at least for old time ops people like myself, it was like observability was a chart that was somewhere else, that like some other person who maybe called me during weekends, or when I was at a movie or in a restaurant or something, that was a, you know, I looked at it as someone else's problem. I think with DevOps or SRE or with the cloud services, observability has come much closer to the DNA, and so yeah. But we're not finished. It's a road. It's a long road ahead of us. But if you're starting out, at least from my personal experience, if you're starting out with chaos engineering, I found that this is the low-hanging fruit that makes it easier to sell to management, to get management buy-in. Not saying, you know, we would be testing out not the product but the monitoring, because nobody ever tests the monitoring. So it's not exclusive at all. But yeah, it started out well for us, and it also, you get sort of a satisfaction because you get feedback pretty much instantly that it works or doesn't. So it's also nice when that comes in. To go as far as generating cascading failures or retry storms or these things, we are not near that in production anyway, but that is at least the hope. But it takes time. It takes a long time to trust the resiliency, to trust the chaos. Another part in chaos engineering, which we're also looking into, was, for example, security. And that says to test out your security. So you would actually pen test using chaos. That is also just, we haven't started it, but it's one of those things that we would like to do, like break into our own systems deliberately. And does anyone notice if I do? So yeah.
I think one, go ahead, Sumit.
Yeah, I like the analogy, designed for sleep. It would be really good. That should be principle. Use chaos engineering and your developer will be sleeping. And no one will disturb that. We do have a lot of observability related work, though I think we were not able to attach the chaos engineering with that. But attaching that is a really interesting thing. Though most of our experiment, we rely on a core hypothesis of that uptime, response, and that. And those were the two things which we validate. And in our scenario, our logging system is a centralized. So we usually don't go and look into the log. So we go and look in the centralized one and figuring out. And then the recent one, which we have actually enabled with the Argo. So Argo has a lot of logging and tracing already available. So you run a pod and then you will see that what's happening behind the scene, or what inject it done on that specific namespace, and you will go able to go and see. So there are a lot of information available what you do, but still there are a lot, as you mentioned, I think it's a journey. I think we have to see how we can spun out.
I think just to add what Christian was saying, just reminded of some cool projects on the CNCF landscape. Forest of logs, I like that analogy. A forest full of logs and metrics, how do you find out what is relevant to you? There are some interesting projects like Zibrium and others who are working on something called anomaly detection. So they are able to identify certain failures in the system and then go back and try and point out the logs or highlight the logs of a particular component in a system that they feel might have contributed or holds information regarding that particular failure. And there are other organizations taking the same path, Christine, with respect to chaos engineering. I know of Signos, another organization which was using Litmus for trying to figure out whether their observability was, but they are basically an APM framework, and they were trying to see if they had the right metrics being captured, they had, if they were doing the right thing with respect to calling out incidents, things like that. So that's a really interesting use case, which is picking up. And there are, I think there's a lot of the APM infrastructure providers today, vendors are working on this area. Some sort of anomaly detection at some level is being made a part of their portfolio, and they're trying to make it easier for SREs to catch that information. I think that's a very interesting space to look out for, and I think it's very closely aligned with chaos engineering as a practice, and we might see more of that in the future, I believe.
So Kartik, one of the very interesting thing which we have done, and I think we shared that, is the integration of a captain kind of SLI SLO concept. So adding that as part of another gating mechanism from the observability with one of your Prometheus or other APM solution is also one of the very viable solution. And I think you guys are working with the captain team on that. So probably if that all the goodies are coming as part of the chaos engineering, that would be really, really awesome for others to adopt.
Yeah, I truly agree.
I actually I like Kristen's statement about information bit, wherein if you kill 3 pods, I know for sure that the application is not going. I mean, it's not going to work. So it's very important to understand the kind of information I believe that we are gaining from any sort of experiment that we are performing with respect to chaos engineering. So in chaos, we have the factor of hypothesis, and I believe that's seen a very large shift from being using CRs as of now, and we used to use JSONs and YAMLs previously. So how has it evolved, and how does it affect the way we perform chaos experiments is something that a lot of folks are interested in knowing about. So Sylvain, Kartik, Sumit, anyone? Yeah.
Yeah, so I think that's one of the things that's happening with cloud native chaos engineering or Kubernetes chaos engineering. Now we've brought the process of describing an experiment into a CR. That's happened. But ultimately, like Sylvain mentioned, we wanted to give the scope for the experimenter to say, this is what we want to really do. The CR is basically lends itself to the model where you're very easily able to store it in your Git repository. It lends itself to GitOps. You can run it in a CI/CD pipeline. But at the same time, I think because we moved to this model, it's also important for us to be able to have the right smarts to allow even the offhand execution of chaos, so to say, the experimental kind of chaos, where you are able to define a lot of complex checks if you want. So hypothesis essentially is describing a steady state. This is what you think is your normal mode of operation. And you feel that when you do so-and-so chaos, you expect so-and-so behavior on your end result. We have the control group and the experimental group. Your control group is showing some characteristics, and you assume that your experimental group is going to show the same characteristics despite chaos. And when you say characteristics, it might not be just 1 or 2 things. It might be a set of things, a set of complex conditions. It could be checking out some metrics. It could be checking out the state of your cluster, or checking out the state of certain resources in your cluster. With all the stateful applications coming on to Kubernetes, and especially with OpenEBS community, this is something that we are seeing as a trend. A lot of people run Postgres operators and Kafka operators and Cassandra operators and things like this. And a lot of application state is stored in CRs. But they want to do these experiments. They want to go look at the CR to say, okay, this is the state of my app cluster. Is it really good or no? So metrics could be something, state of your resources could be something. Some people want to run database integrity checks. They want to go and after they've done some chaos, they just want to go run an integrity check against the database and see everything is all right, for example. So a lot of things that contribute towards hypothesis. Hypothesis itself is composed of behavior, steady state, and steady state itself is very diverse. There can be a lot of things you can count as steady state. So now that we've moved to this CR model, I think it's necessary for us to be able to bring in that description also into this declarative framework. Get your CRs to describe it, or it could be CR, or it could be a JSON file, which is again a declarative way of describing your chaos intent. Then there are some interesting things that have come up in this space. Chaos Toolkit has probes, Litmus has another kind of probes. It could be about hitting some HTTP endpoint, saying that this is my downstream app. I'm going to kill a dependent app and I'm going to see my end application, is it really there? So that's one of the things that's there. That's one way, some kind of progress we've seen in the cloud native chaos engineering world, where you're able to describe that this is what I would like to see happening as part of my steady state being maintained. This is what I want to check. And there's been some activity on the Litmus side where you're able to do something very similar. You're also able to check the state of the Kubernetes resources, or you're able to execute certain commands to verify the state of your cluster or your application. You can run some, you can just launch some pods just as you're doing your chaos. So pre and post chaos is one way of doing it. But even during the course of chaos, you want to see certain things happen. And then there's a lot of these acronyms that get thrown about in the resiliency world. Your mean time to failure, mean time to recovery, mean time between failures, things like this. So you want to capture all this information. That would be a part of a larger hypothesis. I really like the idea of complex chained experiments, which Christine mentioned some time back. So there, even the hypothesis becomes not just one or two things, it becomes a list of things, it becomes a checklist. So there's a need for us from a framework side and also from a practitioner's side to identify the right checks, which is a very difficult thing to do. You need to know your applications quite well, identify the hypothesis, and then be able to transfer that hypothesis onto your declarative way of defining your experiment. I think there is a good progress being made in that direction, but I think more needs to be done. Yeah. That's my take on hypothesis. Hypothesis is really important. It's one of the core principles. If you go to principlesofchaos.org, you will see hypothesis as core principle of chaos. And for us to be able to codify that hypothesis, earlier scenarios would have been written down. You had it in your mind and it was there, the SRE's brain, and then you take a look at it. Now you're not getting rid of that, it's still there. But at the same time, with all the new cloud native spin on chaos engineering, there needs to be a way to codify that hypothesis onto your experiments, and that's something that's interesting that's happening in that space.
In Chaos Toolkit, we've often user can't understand why. So in Chaos Toolkit, you've got the hypothesis that you play before just to check the system is not already off. Otherwise, what are you going to learn if you're already in trouble? And then what we play is method. Admittedly, we're probably a little too academic about the wording, but the method is basically, usually seen as the condition turbulence you're going to bring into the system. But a lot of people get confused why we can also run probes from the method. They don't see the point of it, because probes are meant in Chaos Toolkit probably more as a read, query the system for some information. Your probe shouldn't have any impact on the system. It's morely to query the system. And one thing we often say to users is you need to be ready for the operational surprise again. So while you crafted your experiment to say, I'm going to terminate a pod or do this or Y, and I should, my baseline here is well understood. That's my steady state over there, and it's well understood. You should collect. And one Chaos Toolkit is a little, heuristic over there, you probably should have observability, because what you want to do is at the end of the experiment is go and collect information about the whole system. Chaos engineering is very systemic. While your problem is local, it can have ripple effect where you didn't think about at all. You can actually have an impact on another one, on another team. Your system is all good, and it's a typical, you know, I've tested it, it works. It doesn't really mean a lot, right? So what you do in the method of Chaos Toolkit, if you start having probes, they're not about querying the system about the experiment itself. It's more about querying something else, you know. And at the end, you analyze, you know, all of it. And if your experiment didn't deviate, you still have information about, but did the system or somewhere else deviate at large? Can I correlate, not necessarily create a causation here, but correlate me running an experiment with something somewhere else that happened in the system? Because that's the operational surprise you didn't know about. And that's probably the you know, the dark, what they call the dark debt, I think. You know, that thing that only surfaces when you don't want it to surface, right? That's what you're sometimes, and it's not just the goal of chaos engineering, but it helps. Chaos engineering will help you surface what you don't know, you don't know, right? And I think that's really important as well, because, and obviously having great observability stories is fantastic, because it will do so much more than any probe could actually capture. But if you don't, if it's already you know, did I see any other alert? Did I see any other error somewhere? That could be something you probe for, you query, so that when you build your report after that, you have that context overall. So I think the hypothesis is something, but because it states, I'm going to check the baseline of, you know, my steady state under a certain point of view, we usually can have at that Netflix probably a very business point of view, or saying, you know, how many streamings am I doing? And it's extremely high level, it's really business oriented. And until this is, you know, impacted, I'm all good. But usually, like, you know, we've seen today, you don't start there. You know, everyone thinks they are Netflix or Google, and you're not. So take your time to get there. And maybe start thinking, you're going to look, for example, you're going to terminate a pod, and maybe you're going to look at, did he actually even, because it's Kubernetes, it should come back to life, right? But how long did it take for?
Yeah.
That's already something your application probably, did it actually terminate gracefully? Just to give you an example, back in the day when I was, you know, a different team and doing development, they used an idea where instead of typing Control-C, because I was running the thing from my command line, so I would hit Control-C. They would use a red button in their IDE to kill the process under development. So they never actually tested for the receiving a signal. So basically they weren't a good citizen of terminating gracefully at all, because to them it was always send the sick term, harshly sick kill, basically. So that's the sort of thing that usually you start with. You know, you realize your developers are like, oh, I need to stop in a given time, you know, time frame, and restart in time frame. I didn't think of that. But it's good that you start collecting other information about what ripple effect you had on the system, in my opinion, as well.
Yeah, so there is a very interesting thing. I think there are two analogy I just told, say that one is the ripple effect, and the second one is that, as Sylvain, you mentioned about that hypothesis. For today, when we do one experiment, we validate more than 30 data point on the Kubernetes cluster. That itself tell that, like, we have the full insight or full observability of that platform. And that information we push it to that. So the thing is that when you do ingress pod delete, what would be the impact on the overall system is something which we were not able to do that. So hypothesis and using probe and giving more and more observability as a part of your experiment is the key. One other thing which we did that during hypothesis and the action, there is a some gap, right? You have 10 second, 20 second, 50 second, some gap is there. How you can monitor that? So unless you have some very sophisticated observability platform which capturing that information, that's good. But what we have introduced is that during that time, we started running the performance test. So now you are running the chaos test. You started running the hypothesis and you gather all the hypotheses, and then you did the action to do some chaotic operation. And then during that time to the next time when your next hypothesis will come, there is a time lapse. So we measure that, and that's how we measure the hypothesis with the observability and have some conclusive report that yeah, something need to be fine-tuned. And the 502 sick term thing which we found was one of the crucial thing in that.
That's really cool. From our side, just kind of to add to this, I think that a challenge that I've seen in teams and happened to us when you're adopting chaos engineering is you can try to do too much at first, and then you get swamped by all these things you have to take care of. So for us, what we did was we took this hypothesis as kind of a very business-driven goal of like, hey, what do we need? We need to ensure that people can log in. And then from there, we just added 2 or 3 data points, ran our experiments, saw the results, fix them. And this kind of allows us to always keep in mind what we're testing for, because we're a small team. We don't have, you don't have an infinite time. And with testing, you can go forever and you'll keep finding things. For us, it was very, very important to have this business-driven idea of like, what are we validating? Are we validating, in this case was login, kind of like the first thing, account creation. And then just added 2 or 3 data points, measure them, because we were not as mature in our practice as others. And that's something that, as I talk to other startups, it's kind of an easy way to start, so that you don't feel like you need to invest months on kind of like building your observability stack and months on kind of getting your log pipeline before you can start chaos testing. And you kind of start quickly, small, and kind of as your team gets used to it. And someone mentioned like you have to trust your resiliency and you have to trust your team before heading too deep into this. It's a good way that we've seen to foster adoption, to kind of sell the concept to others, and to make it part of the developers' day-to-day toolkit, rather than this special, oh, it's chaos testing day, which is something that we definitely wanted to avoid.
Okay, so as of now, we can say that chaos engineering as a discipline and as a job description is pretty much a reality, I guess. Like we have DevOps engineers today, what are some of like the skill sets that you would possibly attribute to a chaos engineer? And as a parting comment, I guess, what are some of the things that you would like to see in this discipline going ahead in the future? Those are the 2 areas that I would like all the panelists to give their views on, if possible.
My answer to that is don't turn chaos engineering into a role if you can. It's a mindset. So if you have a chaos engineering team, it's like DevOps. In my opinion, you're doing it wrong. So you don't want that. Chaos engineering, if you really need to have chaos engineering as a role, it's probably more the person who's going to promote and perhaps do the tooling, if you will. But that shouldn't be, you shouldn't have, but that's just my personal feeling. It's a mindset that everyone should gradually adopt, right? So there's a long road ahead and we'll get there, but yeah, don't make it a role. Or it's just in a fairly large organization, it's going to be the person or the team that is responsible for promotion. So it might not even be a role, it might be just a lead or something like that, and tooling. As for my perspective on what next, I don't know, it's hard to say. Probably on the fault injection side, like I said, I would really love if cloud providers, Kubernetes, all the platform we're using have a native interface to it. It would be so much simpler if instead of doing some crazy Linux shenanigans foo on to actually impact the network, it could be provided by the Linux kernel directly. It probably is, but it's such a very complicated way that it's always a pain to set up. So that's for the fault injection side, and I think from the from the high level aspect is it'd be lovely if the experiments could be shared across teams and across organizations. So I'd love to see that, having people being able to say, this is an experiment we run on AWS for that scenario. It's open to the community. Why are we keeping that? Let's say what we did, and we promoting that experiment, and everyone can actually grab it, like source code basically. Get the thing, it's a file, and run it. It would be fantastic, because then we would have a spread of knowledge, and instead of everyone starting from the same level, from scratch, being able to tap into, what your communities, other community have done would be top notch for me.
Yeah, just building on what you said, I think you have summarized correctly. It is a mindset. Chaos is a mindset, and if we have to inject those principles that every team will do that, that would be awesome. Coming back to the, I think, which you mentioned, Sylvan, I think sharing this knowledge is really key. I know that Chaos Toolkit have a catalog, even Litmus has a Chaos chart. I think those were some very good way where you can share your knowledge, and the community can just take a benefit out of that they don't need to start from scratch. They have already 50% of the scenarios or the setup ready. They can just pick and do that. And that boost will actually help for adoption of chaos engineering more quickly than any of the other best practices.
Yeah, I completely in sync with what Sylvain and Sumit just mentioned. I think DevOps is a cultural thing, just as chaos is. I mean, chaos engineer, I find it a little bit strange, because everyone is really a chaos engineer in their respective area of work. The other thing about where the community is headed, where the practice is headed, I also agree with Sylvain on the fact that chaos engineering, if provided as a native option, would encourage a lot of people to try that out and adopt it. And it comes as probably a second nature, second thing. I think you can already see a lot of cloud providers providing native integrations for CI/CD. They have their own registries, they have their own workflows, all sort of things. I think chaos needs to be added to that list as well. So that will make it much faster for adoption, and also the resiliency as an important thing. Chaos first, it's called the chaos first principle, and that's what we're reading nowadays today. Will become really true. And the open knowledge that's available on chaos engineering in the form of blogs, and the panel discussion is a good example. I really learned a lot today, I'll be very honest. And things like this, as also the fact that putting out more information about the scenarios and experiments. For example, pod delete in Kubernetes might sound like an innocuous thing, but it is capable of unearthing a lot of things. So when someone is going to execute a pod delete experiment, what all possible things can they look into? Kind of thing, if we can put that information out, and there's a wealth of knowledge that is coming in as chaos adoption increases. There are different projects that are working on chaos. I think OpenEBS inspired us to start Litmus, and I am sure Chaos Mesh had a similar story with TIKV. So there are different perspectives, and Sylvain is coming from the point of defining open standards for experiments. All this information, all this knowledge, I think should continue to, it's going great. I think we should continue to probably put out that information, give that knowledge to folks. And I think, like I mentioned right at the beginning of this call, a lot of people are still coming to Kubernetes. I read some recent survey by Datadog, which was saying that more than 50% of their users who are using containers are using Kubernetes as the default orchestration platform. But there's the next 50% of users who are either still using containers, they might be using ECS, or they might be using the older Docker Swarm approach, or they might be still on VMs. And now they are going to actually come to Kubernetes because it's just eating up the world. They can get access to this information. it will help the community greatly. So I think I'm all for that. I think the CNCF is also doing a great job in terms of trying to put that information out in the public through its sites and all these kind of things. And there are a lot of meetups that are coming up in different parts of the world. So I think the knowledge around chaos is going to increase. That's what I see happening. And it's a really positive thing. And then, of course, the adoption will follow, and the framework enhancements and other things will follow from there on, is what I believe.
Then, Ramiro, your thoughts, please.
So I don't have.
Go ahead, Christine.
I was just going to be very sure. I don't have that much to add to it, because I completely agree. The only thing is with the mindset part, just have a sense of curiosity and not to be too afraid, because you may break something, but that may be necessary for the path. So I think a curious mindset is really, really, really necessary to be able to be successful in this.
Yeah, I agree. And for me, I see this role as something, especially for large organizations, as more of an advocacy role. I think what Sumit's been doing on Intuit, you know, on your blog posts, your talks, I think that's the right approach. I think that's how you convince, you know, this whole thing about leading without having like the role, just through influence. I think is super important for these practices. And as for the community, I would love for someone to build a project where I could just tell them, hey, I'm building a, I don't know, REST-based API. And they'll just like scaffold me a bunch of experiments, dashboards, everything. So, you know, makes it easy for me to start. So I can, you know, get that first 20, 30%, you know, something very pragmatic, but I like the idea of like a scaffolding of, oh yeah, the first 10 experiments is one click, you have them there. And then, you know, you grow from there. Kind of the same thing that Facebook did with their Create React app script. I think those things sometimes seem trivial, but it really lowers the bar of adoption. I think it's something that for chaos engineering could help a lot.
Well, thank you everyone for being part of this panel, and it's been an immense learning experience for someone like who's just like really started out at the start of this year, and it's genuinely been such a pleasure hosting you all on a Saturday when you all could have been literally doing anything else, including Netflixing and chilling. So thank you so much for being a part of this panel. Over to you, Kartik.
Yeah, I think it's been awesome. When we envisioned this panel discussion, I think the invite also talked about some 1 hour session or something like that, but we've gone far beyond that. But I think it's really been worth the time. A lot of amazing thoughts. I'm sure the community is going to find this very useful, and I think it's going to help them internalize more about chaos and then form their own perspective and then go ahead with their journey. I think we've got some real quality opinions and thoughts discussed here. I'd really like to thank Sylvain, Christine, Ramiro, Sumit, and Divya for joining this discussion today. And thanks, Prithvi, for all the outreach and helping set up this discussion. I'm really looking forward to doing more of these as the chaos engineering practice and as the discipline continues to grow. And I'm sure as the projects tend to mature and as the adoption increases, we'll have a lot more use cases and things to discuss. So I'm really looking forward to a future session of this kind of a discussion. Once again, hearty thanks for joining this session and really making it awesome.
Thank you for having me.
Thanks for the invitation. It was great. Good seeing you all.
Thank you very much.
Thank you.
Thank you. Bye.